Right now we're going to show that the area of the parallelogram that two vectors form, when I do that parallelogram, calculate that area, it is equal to the magnitude of the cross product vector that those two first vectors made. To make it a little more believable for you, I'm going to actually design my parallelogram. And I'm going to do it this way. I'm going to have two vectors, and they're going to be 60 degrees apart. And the length of this one is going to be 1. And the length of this one is going to be the square root of 3. I'm going to call this vector u. I'm not going to set it equal, but this long vector here is u, and this one is going to be my v vector. And if you remember from trig, I'm just going to drop this down and I'll be able to get my components of my vector. But let's first of all I want to ask you, what is the area of this parallelogram? Well, if you remember from our triangles, if I cut this in half like that, I have a triangle situation. You remember that formula is 1/2 the base times the height. But I have two triangles here making this parallelogram, and so my area is going to be not 1/2 the base times the height, but just simply the base times the height. In this case, my base is square root 3, and my height is going to be the sine of 60 degrees times 1. The sine of 60 degrees, go back to your flashcards, is square root 3 over 2. So my area is going to be square root of 3 times the square root of 3, which is 3 divided by 2. Now watch. My first vector, u, is square root of 3i. And that's it. No j's, no k's. It's only going in that I direction, the x direction. My v vector does a little bit more complicated, not much. This, if you remember, is 1/2. So I'm going 1/2 in the I direction and up square root of 3 over 2 in the j direction. And again, no k's. So now I want to do my u cross v vector. That's going to be, even though I don't have k's here, I still have to do it. I have to do the 3 by 3 determinant. I, j, k. The reason I do is because these vectors, when I do the cross product vector that I form comes out of the board in the k direction. I have to make allowance for that here. U is square root of 3, 0, 0. V is 1/2 square root of 3 over 2, 0. So u cross v then is equal to the I, and I'm going to block off that row and that column, times 0, 0, square root 3 over 2, 0. It's pretty obvious what that determinant is. It's going to be 0. Minus j times, block off this row and this column, I'm going to get square root 3, 0, 1/2, 0. And again, it's pretty obvious what that determinant is going to be. That's going to be 0. Plus k times, now I block off this row and this column. I have square root 3, 0, 1/2 square root of 3 over 2. Square root of 3, 0, 1/2 square root 3 over 2. This is 0. This is 0. This is equal to square root of 3 times square root of 3 over 2, which is 3/2, minus 0 equals 3/2 k. And very obviously, the magnitude of 3/2 k, that vector, is equal to the 3/2, which is what I knew I was going to get. The area of this parallelogram is equal to the length of that cross product vector.